So my name is Ghaleb Zekri. I'm an NSX senior system engineer within the technology and practice team. I'm covering EMEA. I'm very happy to be here today to present the practical path to NSX. I'm going to talk about what is NSX in a technical way and what are the main use cases that we address with NSX and how you can succeed a project with NSX. We're going to start with the agenda. So NSX introduction will help us to go through the NSX definition, what are the components of NSX, and what is basically the purpose of this network and security virtualization. And then we go through the use cases, which are mainly the security use case that, as you already seen this morning in our keynote session with Jeremy Van Doorn. The automation, which is really important to deliver the network and security service at the speed that businesses need today. And also the application continuity, how to make your application or the applications that business needs today continuing and available for their customers. And then we can conclude with the statement where you can succeed with delivering NSX projects. So let's start with the beginning. So first, if we take a look a little bit deeper on your data center, we have physical infrastructure basically based on network devices, making switching, routing, and more layer 7 services like load balancers, firewalls, and security devices. And we have compute and storage that store and process the applications. So on top of that, we have the virtualization layer. Mainly, the virtualization layer is about the compute, the virtualization of compute, consolidating, delivering the VMs and the workloads. The main thing here about the network is that when you would like to deliver a service across a network, you build your network configuration on the vSwitch, so you configure what we call the port group, and the port group is synonym to VLANs, and then you replicate the same configuration on the hardware side. So mainly what you face with the speed that the business is requiring today is a challenge to make changes on the hardware, where it relies on adding new VLANs, extending them to the core, and then maybe, and sometimes, readjusting or changing the routing table. And more than common is to change the security policy to deliver these services. So what we did with NSX is basically we took the virtualization layer and we enhanced it with the network and security services that you usually use on the physical side. We did this for two reasons. The first one is to make the network and security taking advantage from the same agility that we have with the compute and the storage. So delivering VMs takes minutes. It takes probably hundreds of VMs could take hours, while changing configuration in the network, and you already aware about that, changing configuration on the network could take weeks, days, sometimes months. The reason is because this physical infrastructure, is really sensitive to change. It's shared by multiple applications, and every time you need to change it, you need to open a maintenance window, and then you make the change, wishing that there is no error in there that could disrupt any applications. So the other thing is that with these services inside the virtualizations, we can deliver them at the same speed as we deliver VMs, so in minutes. We can enroll them to the application without impacting the hardware infrastructure. So we can make the hardware infrastructure stable and reliable and non-sensitive to any change. So if you configure it for some time, for delivering the service in data center, they will not be sensitive to any application change, where the application will take all the benefit from the network services and the security services that will be closer to the application and take more advantage from the context that we can deliver about these workloads. So these service network and security services are mainly the switching. So we can switch between applications sitting on the same layer without taking care about their location, if they are on the same host on different hosts. We can even more build multiple layer 2 without connecting them together. So we are isolating them from each other. We can route between them wherever they are, if they are on the same host or not, without sending the traffic back to the hardware infrastructure, going to the core of the network, to layer 3, and then getting back to the same host, which costs a lot in terms of performance. And we can build the security policy the closest to the VM, so we can stick it to the VMUG. And then build the load balancing services inside the virtualization environment and stick it to the application itself. The other advantage is that we take these services and we distribute them across the whole compute infrastructure. So anytime you need more performance for the compute and you add a new host, new ESXi host, you dynamically and natively added more performance to network and services. That's what we call the scale-out approach, compared to the scale-up, where in the hardware infrastructure, every time you need to increase the performance of the hardware, you need to re-architect the network, or you need to change boxes. So with that, we can take benefits from the high throughput rates that we deliver through the whole compute infrastructure. So we can deliver, for example, firewalling, 20 gig of firewalling per host, and then you multiply that by the number of hosts you have inside your network. We address the east-west traffic problem or challenge. Mainly, if you build your security in the legacy way, you define a security zone, what we call perimeter, and then you put a firewall between security zones. And that makes zones of trust that could probably be the weakness for lateral movement for malware. So malware inside specific zones, where we consider that every component in this zone or every workload in this zone have the same trust level, okay? Then if you if an attacker have breached one of these workloads, he has access to all the other workloads, theoretically all the other workloads, without any action from the security devices, because we are already inside. And we consider it by the default that all the workloads inside the security zones have the same security trust. So with the firewall distributed across the hosts, we address the east-west firewalling traffic. And then, as I said, the native platform capabilities. So you have, anytime you add a new compute, you have more performance on the network and services side. So that's why we present NSX as what we call the network platform. So network platform now is not only the hardware devices you have in your data center. It's also augmented by the capabilities of network services that we injected in the hypervisor. Okay? So based on that, we will have virtual networks built inside this infrastructure, inside your hypervisor, with switching, routing, firewalling, and load balancing that could be consumed by the application itself. When you land an application, it's automatically delivered with the network and security service enrolled with it. And that will augment your automation capabilities, not only to deliver workloads and then wait for the network to be configured to have this application available for your customer. It's already built with the network and service security services requirement for the application. So that's why today we are seeing a great momentum for NSX. We are in growing momentum where we have more than 1,700 customers adopting and taking advantage from NSX. More than 100% year-to-year growth. And we can say that we have more than half of these customers today, the numbers increasing day to day, that are in deploying or in deployment process or already on production for NSX. So from our side, we have 8 out of VMware's top 10 deals, including NSX, and this is significant for our customers and for us. So we can see here some logos. Many of them are also subject to compliance with the PCI DSS, with GDPR, with national government, and so on. So if we come back to the 3 use cases, the 3 customer use cases. So the majority of the customers saw the advantage of the virtualization of what we call the software-defined data center. So software-defined data center is the virtualization of the compute, of the storage, but also for the network. And for the network, the product is NSX. And it addresses the 3 main use cases that are security, automation, application continuity. Security is for microsegmentation. You saw this morning from the keynotes that Jeremy presented, how important to build a zero-trust security architecture. So the new architecture that delivers security embedded to the application, to the business. So that's what we call microsegmentation. Secure end user, because you still have the requirement to provide least privilege. So if someone is using an application, you have to make sure that he is using only this application and not any other workloads sitting on the same layer too, because your architecture is built in this way. And the third one is DMZ anywhere. So no more security zone or perimetric zones that we call the same security or the same trust level. Every VM will be a DMZ. And without that said, we build that without increasing operational costs. That's very important. The second use case is about automation. Automation is how you as an IT, you behave as a cloud provider for your own IT infrastructure. So how you build your IT in a way that businesses can consume them like they consume cloud services in Google, Amazon, or Azure. So automating IT by IT. It's also how to deliver infrastructure to help developer inside the enterprise to consume them. So that's what we call developer cloud. And also how to build multi-tenant cloud. You can have a situation where you have multiple team or multiple business, and you need them to be hosted on your infrastructure in a multi-tenant way, and every business have access to his own resources or his own application, while consuming some shared services, by the way. The app continuity is about to address disaster recovery, multi-data center pooling. So we have to build multiple data centers across the world, but we need to that the business see them as only one unique virtual data center, how to do that. And also how to build a cross-cloud architecture. And you probably heard about the announcement that we made in VMware with Amazon, VMware Cloud on Amazon, and AWS, and also with some partners like with IBM, with SoftLayer. So let's start with how to get started with NSX. So our advice to start with NSX is first to learn about NSX. NSX is a journey, is not a step. It is a journey in your delivering or architecting your IT or your network and security services. So you need to learn about it. Then start small and grow. Start with some use cases that you believe that are relevant for the business, and grow and extend these use cases to others. And then leverage best practice and validated design. We have a bunch of documents, white papers, validated designs, and we have a very rich ecosystem of partners that can help you in delivering your architecture and your use cases. So let's dig a little bit on the use cases that we are talking about. So first of all is security. So what is microsegmentation? The microsegmentation is the fact that you can build inside your hypervisor the separation or isolation between different components in your data center. So we can build a sample isolation by not connecting different tiers between application or between businesses together. So we build layer 2 across multiple hosts without connecting them, without building routing between them, so they are completely isolated and they can't see each other's. The second thing is to deliver an ecosystem for an application where we have a multi-tier application, and we have components on each tier that we need to secure. We need to make sure that they can reach only the right component. The web can reach only to app, and the app can reach only the database, not the web to database. Independently from where they are sitting, if they are sitting on the same layer 2, or they are sitting on a different layer 2 from the hardware perspective. So we can build routing between them and then complement with the firewall services that are natively implemented on the VNIC. And third, we can deliver advanced services. Advanced services, so we can selectively redirect the traffic for a specific component for a security VM from our ecosystem partners that could deliver up to layer 7 security services. If you are complying with PCI DSS and you need basically to have an IPS inspecting the traffic coming from the web to app, so the easiest way is to take this traffic when it comes from the VM, the web VM, and redirect it to a security VM without doing any traffic engineering. That's what NSX delivers. So wherever the VM is sitting, if it's in host A or host B, or even if the VM moves across the data center, we can maintain the same protection level with the same security services that we delivered before moving the VM. So that's what we call advanced security services, and we have multiple security partners working with us, like Palo Alto, Checkpoint, Fortinet, and Micro, that can steer the traffic and make the decision based on layer 7 security policy. One of the most interesting use cases is how to secure the east-west traffic in a VDI infrastructure. You know, when you build a VDI infrastructure inside your data center, you extend the surface of exposure of your data center, because mainly the users now are inside the data center to consume application in the data center, and sometimes to go outside the data center to internet to consume other applications, like cloud application or software as a service or whatever. So the problem is, basically, with the legacy infrastructure, when you build your VDI and all your virtual desktop sitting on the same layer 2, users can connect to each other in the same way they do when they are in the remote office. Okay? So now, because they are inside your data center, they increase the risk for your own application. So it's really, if you need to implement security in the legacy way or in the physical way, it's highly cost for physical segmentation and hard to implement, because by definition, by design, users are moving a lot. You have different type of users. Users move from department to another, and you have to change their rights. You have, by the way, to change the security policy, allowing them to go from one zones to another, because they basically change it from one department to another. So what we find in most of the cases, so someone who moves from marketing to, for example, engineering, or from engineering to marketing, this guy have the new rights to access to marketing resources. But if we take a look a little bit deeper, his rights to access to engineering resources are still there. The firewall rules never been deleted. So he still have access to some critical resources. So with micro-segmentation, what we're going to do is, basically, we can enforce desktop-to-desktop control, because when the user access to his VDI or virtual desktop, he automatically will be identified and get his controls or his security policy sticking to it. We can also control desktop to enterprise. When the user moves from one department to another, the security policy make him moving from a security group to another that stick with his new role. And we can complement with other security services to maintain compliance or maintain protection. When it comes to the VDI of this user is compromised by malware, we can dynamically adjust the security policy based on his new security posture. So we can use also services like load balancing or edge firewall to provide access to, for the real user to their virtual desktop. And we can also leverage a function like nav VPN. And the most important benefit is also the elasticity to spin new pools. So dynamically, you can add users without having to change or to make a significant change in your physical infrastructure. So the second use case for security is more about DMZ. So how to deliver inherently secure infrastructure. So we have here users accessing to a data center with a perimetric security built by a data center firewall. And then when it comes to a user accessing to a specific VM, with NSX delivering the micro-segmentation, we can make sure that this user, when it accesses to this specific VM, will not move laterally from this VM and go to another VM without being blocked. So, sorry, we can build a secure environment with a zero trust architecture with more security inside the data center at the third of the cost and less operational cost than the hardware infrastructure. We can build a very simple security policy that adapt the protection level to each type of users. And then we can stop the kill chain, basically, because if, in case of we have a compromised VM, we contain the threat inside this VM, and we put this VM in quarantine zone, where the only access that will be allowed is to remediation zone. So we do that automatically and dynamically without any human intervention. So how do I get started with microsegmentation? How do I move from legacy security policy, from operational perspective, to this new architecture? It could be, for sometimes, it could be perceived as really hard. So first, we prepare infrastructure for NSX. We install NSX. And then we create a default rule to allow and log all traffic, or we can use, even more, we can use VRNI, Network Insight, to detect what are the traffic that are flowing between the VM to another. And then we create shared services rule, where basically we will detect where my application are going. For example, for DNS, are they using a specific DHCP service? Then we can onboard new application and start with existing application. So we can easily, from this analysis, identify which new traffic or which existing traffic we need to filter. And we use NSX toolset to dynamically determine the required rules, like syslog, IPFix, or NetFlow, basically with VRNI, to detect which traffic have to be filtered. So VRNI, for example, can make some advices about firewall rules from one security zone to another, or give you more visibility and deep visibility on where the traffic is coming from and going to. We create then an east-west intra-application rules, and we continue with the other application. When we finish with an application, we create a rule without logging in order to eliminate this traffic from the logs, or we can rely on VRNI analysis and see the new traffic coming and build the rule based on that. let's go through a use case, a real use case, where customers, this is a real customer story, where the challenge was for the customer, he has 2 data centers, and he's delivering basically different environment, production environment, test environment, and PCI DSS sensitive environment, and shared services. And he needs to make sure that production PCI DSS have access to shared environment or shared services without being compromised by threat. So he needs to simplify the shared services for new apps, and he needs to automate the deployment of security. So what we've done here, basically, we provided with NSX the ability to virtualize the access to the services. We automate access to shared services. We make the network topology agnostic on the hardware infrastructure, and with a security policy that isolate the PCI environment from the other environments while delivering advanced services, we will be able to deliver PCI compliance. And the choice was made also because we have a rich ecosystem of partners that deliver advanced security service like IPS for east-west traffic. So here, how customers take benefit from NSX. So in both of these data centers, he built security groups, and from these security groups, he tagged VMs to be in production environment or to be in PCI DSS environment. And anytime a new VM come up and is tagged with, for example, PCI, it automatically lands on a security group for PCI and inherits the firewall policy and security services that are applied to this security group. When a VM moved from one data center to another, it keeps the same protection level. It keeps the same security group and the same security policy applied to this security group. And what is more important is when the VM is decommissioned from the data center, the firewall rules applied to this VM are moved from the data plane. So we have a security policy that is built once and applicable repeatedly forever. So you don't need to make any change for any new application coming that could probably, with some errors, impact existing application. And as Jeremy said in the keynote, how many times you have application remove it without being aware that you need to remove the firewall rule related to this application. So let's go on the second use case. First of all, do you have any question about this? Very clear? Okay, let's go with the second use case, automation. I think this slide will talk to the most of you. So you have businesses that need to use application or to have new application coming, and you have to deliver security and network services as much as these applications are consuming are coming in the data center. So these securities could be delivered by a user interface. So it could be managed by delivering the configuration through user interface, like delivering firewalling, VPN, data security activity monitoring, or switching, routing, load balancing. So it delivers multi-tenant infrastructure. It could address as well the developer cloud. So the intention or the purpose of this automation is basically to reduce infrastructure provisioning time from weeks to minutes. So how we're going to do it is basically to use the GUI. The GUI will have the ability to provision network and security services from a single point of glass, which is vSphere Web Client for NSXV. So that will make these configurations of network and security consumable from workloads. We can do it from programmatically from APIs. So we can easily use the API, the REST APIs, to push the configuration from your provisioning tool, from your own provisioning tool, or use VRA, for example, to build the workload, to build blueprints that consume the existing configuration. Or you can do it from a CMP platform. So CMP platform, VMware CMP platform, vCloud Director, or VRA to provision them. So how it's going to work? So the first customer story is about a customer that have the business requiring much faster application deployment and development. They're using agile method for developing applications, and they are developing development team are delivering application to the line of business much faster. So the challenge was, as a new application come up, we need to configure on the legacy infrastructure the right network and security service to deliver it to customers. And the challenge is that while the time is increasing, the efficiency is decreasing. So we make much more errors, and we increase the time of deployment. The line of the business goes to another option, which is the cloud, Amazon, and that creates what we call shadow IT. From this point, what is the NSX advantage is to provide an end-to-end automation. So we know the automation about the workload and the compute. With the NSX, we will embed the network and security service to this automation. So when we deliver an application, you deliver it with the network and security service sticking to it. And this is specifically configured for this network, for this application. And it makes the policy consistent, because when you move application from one environment to another, the application was built in development, so it's in dev environment. When you need to move it to Q&E, when you move the application, and then it keep the policy consistent, because when we move it from an environment to another, we change the tag for this application, and immediately we apply a new security policy that allow only the Q&E resources to access to this application. When we move it to prod, the same. So we move the application, we close the port that are allowed for dev or for Q&E to make it in production and make it available for the customers. We make the security policy much more granular, because we have this east-west segmentation. We make sure that the VM, if it's sitting on the same layer 2 by the design of the blueprint, we have this segmentation applied to the virtual network. And then it's completely integrated with the vSphere. So it's basically we have a simple and a single pane of glass to have the visibility on my workloads, the network services that apply to it, to my application, and then to security service that are provisioned to it. So by that, we can easily, with VMware ESX, the compute capabilities automation, and NSX and vRealize automation, reduce the time to delivering application from weeks or days to minutes with zero-touch deployment. So that's what we call making these resources consumable from the business line. So when the business line requires a new blueprint to deliver an application or to test a new application, he has to access to the portal from VRA and consume it and provision the required application, and every component will be delivered and provisioned in the infrastructure. The last use case is about application continuity. So the challenge here is basically how to deliver data center anywhere, how to make application landing in the first data center or another data center agnostically, or even more, how to make it deliver it on the cloud agnostically. So it could resolve the problem of disaster recovery. If I have an outage on a specific data center, I move transparently all my application to another data center without or with a minimum of downtime. It could also build an active infrastructure. As I said, I need my application working, and depending on the charge I have on my data center, I can provision it on the first one or the second one. It could address the hybrid cloud networking, where I extend my network, my on-premise network, to outside while controlling the security of my application. So how can I manage this shadow IT as a benefit, as an advantage, not as a competitor? Okay? And the business value from that is reducing the time to recovery or a new availability model. So let's go to the first case. So here we have multi-site infrastructure with the site A data center where we have a vSphere, where we have our own workload on the first side, and we have a site B with another vCenter, with other vSpheres, and we installed on top of it NSX. So with NSX from NSX 6.2, we have the ability to extend our network and security services across these data centers. And then my application here will be hosted by the first or the second site and will be visible from outside as a single one application. My data center are seen as a single virtual data center. So for this, we have a requirement. So we have to have an MTU higher than 1600 and a latency time between the two sites less than 150 milliseconds. So cross-cloud connectivity. So from the private cloud where we built our data center based on network and security services virtualized with NSX, we can easily connect our network to external resources in a public cloud, like we did with some partners, with IBM SoftLayer, for example, where we can extend our layer 2 or layer 3 across the network and have my workloads that are sitting on the cloud, on the public cloud, accessible from my private cloud. So here we can secure also a layer 2 and layer 3 connectivity between the on-premise and hybrid cloud. And here we have the customer story. So one of our customers used NSX with the use case of a disaster recovery. So the problem was, in case of disaster recovery, in case of a site outage, what we have is, first, we have an over-provisioned capacity because we have to consider that in case of failure for one site, we have to have the same capacity on the second site. And then a complex disaster recovery process. It's manual, it's error-prone steps, and it increases the RTO to recover application. And there is no granularity for disaster recovery. It's all or nothing. So if you have something failing on the first data center and you need to move to the other data center, usually what you use is the whole infrastructure is moving and the whole application are moving. So how it works? First, in case of a problem, we have the first VM moving from the primary data center to another. So first we sync the SUN, the storage. So second step, we use SRM to replicate VMs and the storage between the two between the two sites. And then we recover the VM on the other side. And then here we start with networking things. So because this is two different sites, we have to change the IP address or stretch layer 2. And in many cases, the firewall sitting on the second data center hasn't his security policy updated. So we have to go and open or update the security policy to make this application available. So why NSX? NSX make these data centers as a single virtual one data center. So we consider that these hardware infrastructure or these two data centers as a capacity pool of compute and storage and network. We consistently extend networking and security services across the two sites. And with the virtualization and with SRM, we can allow, and with SSDC, we can allow the move from one site to another without need to change any configuration. So we integrate business continuity and disaster recovery in built-in solutions. So anytime you need to build this use case, is not only addressing disaster recovery, is mainly addressing application continuity. So how we do it, we have our VM 10.0.10.21 with basically a security policy sticking to it. So when it comes to move this VM to another site, so we have the same process where the SUN will sync with the other side. And then when the VM moves to the other side, as we have the network services extended across the two data centers, no need for changing the IP addresses. And the security policy is sticking to the VM, so no need either for changing the firewall rules. So now, we have the ability to move this VM and having it available immediately or with a minimum downtime. And we have some use cases where IBM SoftLayer is demonstrating moving VM from Australia to US without losing the service itself. So here we have a consistent network and security service across sites, integration with the recovery manager, SRM, and significantly reduced complexity. No need anymore for operational tasks to update or to change the network on the other side or the security policy in the other side to address the application requirement. Is there any question? Okay, so I come to the conclusion where NSX is the mainstream for these three use cases. So it's the mainstream for security while providing microsegmentation with security embedded to the application. It's a mainstream to automate the IT for the IT. So with the automation integrating the network and security services, we can easily provide our application to the customer, to the business, with a minimum of time, increasing the time to market and so on. And application continuity that address mainly the application, the disaster recovery and business continuity, while reducing the RTO by 80%. So back to the next step for the path to NSX. Start learning about NSX, understanding the key challenges that we address with NSX. Define your requirement for your solution. What do you need? Do you need NSX for security? Do you need it for making network and security service delivering much faster and automating your process? Do you need it for disaster recovery? So you can also start with trying and playing with NSX with hands-on lab. Second one, start small. So start with a small project and add functionalities in phases. So you start with the security, you can add automation, or you can add disaster recovery and application continuity. You can start either with a brownfield, with the existing application, without changing anything from your infrastructure, or with a greenfield, where you can start from the beginning. So NSX implementation can begin at the environment or cluster level. So you can just choose one cluster from your infrastructure and start with it. And then you define the operational model. Depending on the use case, you can define how to deliver NSX to the business. And you can leverage multiple tools like the NSX design guide, VMware validated design, and many partners and services from VMware that can help you in driving your project and driving you to the success. So with that, I ended my presentation and come to the questions, if we have time. Yeah.
Is this a standalone product or is it part of this?
So NSX, the question is NSX a standalone product or a part of suites? Yeah. So NSX is a standalone product for from the BU perspective, but is included in SDDC offer. So we have recently released what we call VMware Cloud Foundation. If you were in VMware or if you follow some new announcement, that is able to provision what we call the stack of the SDDC with the compute network and storage embedded together. And we have SDDC manager that handle all the installation process and the update, take care of the microcodes updates for the hardware and so on. Okay, so this is new, and it's the way how you can consume NSX as a bundle in whole infrastructure called VMware Cloud Foundation, managed by SDDC manager. Any other question? Okay, so thank you very much for your attention, and hopefully I was very clear for presenting this use case. Excuse me for my English. I'm based in Paris, so probably some of you detected some mistakes in English. So thank you very much.